Hello, we are Team 7, and we welcome you to our final presentation of our redesign of the stapler.
We chose the Boston stand-up stapler for our product. Our primary customer base is office and school workers who need a stand-up stapler with a low storage profile. Our secondary customer base is advertisers and extracurricular groups who are aiming to staple things onto walls without caring about stapling individual sheets of paper together, and we estimate an annual production volume of 125,000 units. Here is shown the CAD for our primary module designed for the main use of office workers, and the secondary module designed for use mainly in stapling to walls. Note that the secondary module has removed the lower jaw so it's more convenient for people to be stapling onto a wall, and also reduces the total cost of this module.
Here we have an exploded view of the CAD for our primary customer. We have 18 unique parts, 2 of which are fasteners. When comparing the two assemblies, we can see the advantages of having a large number of parallel assemblies, which allow for a high level of individual part accessibility and an ease of performing multiple assemblies at the same time, resulting in a lower total assembly time and therefore a lower total assembly cost. For these reasons, we have selected Assembly 1 as our primary assembly method based on these metrics here: ease of transferring and handling parts, ease of locating parts, ease of fastening and joining, ease of testing assemblies for their function, and ease of assembling subassemblies in parallel.
For our function analysis system technique table, our task function is binding materials, and our primal basic functions are housing, dispensing, and securing staples. These branch into basic functions of apply force, access housing, separate staple, feed staple, position staple, and form ends, as shown on the figure. Special features of our stapler create supporting functions of increasing grip and reducing footprint to assure convenience and enhance the product. Additionally, it is of note that many steps in the binding materials process are performed by the user, such as loading the staples and adding the material. Our function component mapping matrix uses the subassemblies of assembly diagram 1 in the first column and the basic functions from the previous slide in the top row. Each function corresponds to a part and has less than 40% of the overall parts.
The quad chart analysis has shown parts including springs, screws, and some plates outside the main function are of low importance and cost. The covers are higher cost and low importance, along with a few sheet metal components. The pivot pin and main function small sheet metal components have high importance but low cost. And lastly, most of the large sheet metal components housing the staples have both high cost and importance.
Here is the functional differentiation table, which describes the similarities and differences of the product functions. With our two products, most functions are the same for both customer groups, with the only difference being the form ends function, as they staple different materials and have different needs. Here is the component commonality table, which describes the similarities and differences of the product's components. With our two products, most parts are the same, with the differences being the top cover, parts creating the lower jaw, and additional spacers in the secondary product.
Shown here is our product family assembly diagram. The staple cartridge assembly shown in the top left corner is consistent in both the primary and secondary customer assemblies, and then the lower assembly is only present in the primary customer assembly, and then after that it is differentiated the rest of the way through, shown in the bottom figure, as the top cover is different in both assemblies.
Discussing design for manual assembly, the original primary design had a total assembly time of about 150 seconds, or about 2.5 minutes, with 20 total parts. The main contributors to this were springs and screws, which nest easily and are difficult to handle. With the revised primary design, the assembly time is about 118 seconds, or about 2 minutes, with 17 total parts. The main revisions are that the flange base was modified to snap fit into the bottom cover, and we integrated the lower tension spring into the flange base plate, which removed 2 lower assembly screws. In total, this saved 31 seconds For changes to injection molding for manual assembly, the original bottom cover used screws to affix the flange base to the lower cover. The new design uses snap fits, which allow the lower cover to be integrated without screws, saving assembly time. For sheet metal revisions for manual assembly, the original flange base was affixed using screws and had detents to attach the lower tension spring. The revised design has integrated the spring as a sheet metal leaf spring and includes additional mounting points to snap fit into the lower base plate.
When designing for automated assembly, the original assembly included a screw, spring, and tab, and the top cover was assumed to be the base component. Using DfA methods, an updated assembly is shown with an integrated spring tab and snap fit features. DfA 1, reducing part counts, removed the spring and screw, reducing parts from 4 to 2. DfA 2, reducing fasteners, was also considered when removing the screw. DfA 10, features for installation, and DfA 11, locating features, were also considered by adding press fit tabs and keeping the existing locating feature for ease of installation. This reduced costs from around 14 cents to 10 cents. While the bulk of the cost in either assembly comes from the top cover, it was mostly preserved to not hinder feel or device performance. Changes made should not reduce functionality, but provide a valid alternative.
For process selection, we chose to go more in depth with the top cover and with the catch tab, shown below in drawings, which outline some of the key dimensions of each part. Shown here are the matrices used to determine what process would be used to manufacture each part. After a series of eliminations, injection molding was chosen to manufacture the top cover, and sheet metal working was chosen to manufacture the catch tab.
DfM Pro found the cutout distance to part edge and to bend distance and the bend radius to be some problems here. Those were fixed with our redesign. The improvements we made were filling in the top for simpler geometry, as well as filling in the sides to help with the cutout to part edge recommendation, and shortening the slot for greater strength to fix the cutout to bend distance and bend radius recommendations. The before had a cost of 5.22 cents, with hubs finding that around 30, and after it went down to about 5.08 cents, with hubs finding that as about 6.5 cents.
Here are some of the recommendations DfM Pro had for our top cover, most of which had to do with reducing the section thickness to be more uniform, as well as reducing the snap fits to be a more even length. So some of the changes made were to remove the circular indent to
For Design for Product Service System, we propose an online subscription service for stapler customization and refills. This will provide custom covers to decorate your desk without having to buy a new stapler or decorations, custom staple colors to stand out on your reports, wall hangings, and more, and never running out of staples with a software that tracks how many staples you use and calculates when to deliver more. This will improve customer experience with more customization, mood boosters for the workplace, and lower costs due to less cheap decorations needed to be bought, and lower time costs by not having to make special refill trips. Reduce negative impact on the environment by reducing overconsumption of decorations and inducing a carpooling effect due to new staplers being delivered by the mail. Overall benefits from our design for DfM for total cost savings are 6.76 cents. For DFA, this is 4.176 cents, and DFA also has a total time savings of 31.2 seconds. Some self-critiques of our design is that it reduced cost and reduced time, but that not many redesign options were available due to not having many individual components. If we were to start over, we would explore different secondary customers, which would then give us a different secondary design.